Please go to question number 3 on worksheet number 5, Newton's second law and friction, of the net force packet. That's the same packet that you were given at the end of the year, and Ms. McClelland has an extra copy of it as well. Question number 3 reads that a horizontal 100 Newton force is applied to a 50 kilogram classmate resting on a level tile floor. The coefficient of kinetic friction is 0.15. So here we're going to start our force diagram. So we have gravity acting on that character. Okay. There's also a normal force pushing up. And horizontal means parallel to the floor, so these two forces are equal. The kid is not moving up. Okay, there's our applied force of 100 newtons. We'll just call that force applied. Okay? I'm going to make this a little bit smaller, kind of fit it up there. All right. The coefficient of kinetic friction is 0.15. So that's the mu that we're talking about. It's equal to 0.15. And there are no units on that. First, it asks us to draw a force diagram to represent the situation. We've done that. Now, it asks us for part B to find the force of gravity on the classmate. Okay. Force of gravity is equal to mass times the acceleration due to gravity. The acceleration due to gravity is 9.8 meters per second squared on Earth. So the force of gravity is simply the mass, which is 50 kilograms, times 9.8 meters per second squared. Okay. When we calculate that out, we get 490 newtons for our force of gravity. Okay. Again, I'm going to go ahead and make that smaller. Okay. Here, since our force diagram shows that the normal force is equal to the force of gravity, we also know that the normal force is 490 newtons. And there you've answered part B. We need to find the force of friction on the classmate. Suppose we should add a force of friction. We don't know what that force is yet, but we can find that force of friction. Okay. We find the force of friction by doing mu times the normal force. That's how we calculate the force of friction. Friction depends on the coefficient of friction, how rough the surfaces are, and how hard they're pushed together. So for mu is 0.15. We multiply that by the normal force, which is 490 newtons. We're going to get a value of 73.5 newtons for the force of friction. Okay. There we go. Part D asks us to find the acceleration of our classmate. In order to do that, we need to find the net force. So our net force is going to come from our force diagram. It's equal to the force applied minus the force of friction. So that's 100 minus 73.5. The net force is equal to 26.5 newtons. Okay. Now we need to find the acceleration from that. So we can go down here, we'll say force net is equal to mass times acceleration. So if we do 26.5 newtons is equal to 50 kilograms times the acceleration. We want to solve for acceleration. All we have to do is divide 26.5 divided by 50. Following along on your calculator, you get that the acceleration is equal to 0.53 meters per second squared. There's your solution. Part E is an optional extension. It's a good optional extension, but know that it is optional. On the next page here, I'd like you to solve the following question. All right, here's the problem. A 7 kilogram cart, so here's our cart, is pulled by a force of tension of 20 newtons. Okay, you can see that here there's a string on a pulley, and that string has a hanging mass that's pulling it down. Okay, The coefficient of friction is 0.15, so there is friction pointing to the left. There's normal force up, gravity down, tension to the right, and friction to the left. You have to draw a force diagram for the cart, then you have to find the acceleration of the cart. That's just like what you did on the previous problem. Okay. Then if the cart accelerates for 3 seconds, you have to figure out how fast it will be traveling. That's going to ask for the final velocity. And remember that final velocity is equal to acceleration times time plus initial velocity. Finally, you have to figure out how far it's going to go in that time. That's asking for the final position. And remember, that's the 1/2 at squared plus velocity initial times time plus position initial. You can assume that its velocity initial is 0, and you can assume that it starts here at position 0 as well. Okay. Please work out the problem together on your whiteboard. Take a large whiteboard and some whiteboard markers, or you can do it in a notebook. Solve the problem, help each other out, and let me know if you have any questions. Thanks. Good luck.